Well, hey guys, here's section 10.1. This chapter is over rational expressions and equations. But in 10.1, we're just going to be talking about simplifying rational expressions. So let's first talk about what that is. I'm going to put my name here at the top like normal, Mr. Kossel. Now, a rational, not to be confused with radical at the square root, a rational expression is an algebraic expression whose numerator and denominator are polynomials. So some examples could be 3x divided by 7y, because we have a numerator and denominator. Both 3x and 7y are polynomials. 1/5 is, because if we call 1 and 5 are actually polynomials, they're just more specifically monomials that are constants. And then even actually x squared plus 2x minus 15 could be. One quick recap, not no cap, but recap. How do we simplify fractions? Okay, well, you say 3 and 9. Well, what goes into both those? Well, 3 goes into both, so you divide the top by 3 and the bottom by 3. And so 3 divided by 3 is 1 on the top, and 9 divided by 3 is 3, so we get 1/3. Now, we might not remember that's the math that goes into it, but that is actually the math that goes into it, is we divide the top and the bottom by the same number, okay? I'm going to even write that down here, so I encourage you to do the same. We divide the numerator and denominator by the same value. Okay. Go right below this, and we see some examples. So we're going to work on simplifying these expressions. Now this is actually practice that we had before, really, a few chapters ago when we dealt with exponents. So we want to first start with our constants, 54 and 24, their coefficients in this case. And we say, okay, well, 6 can go into both of those, so we're going to say we're going to divide the top and the bottom by 6. Okay, and I'm actually going to write this out like we had been before, like I did up in the previous example. And then they both have a z in common, so we can divide both the top and bottom by 6z. And if we divide the top by 6z, we're going to be left with 9z squared. Because remember, when we divide variables and this same variable, we subtract the exponent. So 3, the exponent on the z, divided by just normal z is z squared, because 3 minus 2 is 1. On bottom, we're left with 4y. So you have 9z squared over 4y. That's our answer. On the next one, same idea. We're going to divide the top and bottom by the same number. In this case, we'll do 3x, y, z. And we'll divide the bottom by the same, 3x, y, z. We have to divide both the top and the bottom by the same in order for this to work out. Top, we're going to be left with 3x, no y, and no z anymore, because y divided by y is 1, and z divided by z is 1. That's why we couldn't divide by z squared, even though the bottom has z squared. And the bottom, we end up getting 8z. And we can't divide by x squared because on the bottom, there's no more x's. So we see, okay, well, we're just left with 3x over 8z. Now, once again, that was kind of a review on those two. Now, anytime you have a binomial or trinomial, so 2-term polynomial or 3-term polynomial, you have to factor first. And the reason why we have to factor is because we're dividing when we simplify. So you can divide when there's multiplication. So like on the previous examples, 54 is z to the third. On example 1, 54 is multiplying with z to the third. So we can divide that. But if we look at example 3 for a moment, at the denominator, 5x plus 5. We can't simplify that because simplifying is division, and that's addition going on. So what we do when we factor is we create multiplication, okay? So maybe even write that in as a little note, is that factoring creates multiplication. Okay. So it ends up reworking it and making it look different. So it is in multiplication form. It's the same value still, because if we were to multiply it back out, we'd get the same thing. So when factoring, always check for a GCF first, all the time. Now, if you recall, we did make a flowchart about this back when we factored in Chapter 7, but now a few chapters ago now. So when we have two terms, we want to check for a difference of two squares. And we also call this dots, D-O-T-S, dots, difference of two squares. Three terms, we make an x. And if a is equal to 1, the leading coefficient is 1, we use the shortcut. And if a is not equal to 1, then we have to rewrite and then use grouping. And we'll see both of those examples in a bit. So on number 3, 10x over 5x plus 5. So we have a binomial here, so we have to factor first. We can't just say, oh, this has a 10, this has a 5, this has a 5, or boom, or say this has a 10, this has a 5, and call it good. We can't do that because that would end up with 2x over x plus 5, and we'll see why that's not right. So in the bottom, we create multiplication, calling it 10x, and we can factor out a GCF there. There's a 5 there in both, so we can make it 5 times the quantity of x plus 1, because if we were to distribute back in on this bottom here, we'd end up getting what we started with. So now, since we have multiplication on the bottom and multiplication on top, we can say, oh, well, okay, now what we can do is we can divide by the top by 5 and the bottom by 5. And we end up getting 2x over x plus 1. And that is our answer, which looks very different than that 2x over x plus 5 that I wrote in orange earlier. That was wrong. Okay, so we have to factor first in order to create the multiplication. Same thing here on 4. We have addition on the top, and we can't factor that since there's no difference of two squares, and there's no GCF. But we can factor this bottom here, this trinomial. So we make an x. There's no GCF. The top goes a times c, if we recall. So 1 times 3 is 3. And the bottom, we put our b, so that's 4. Well, we have to have two positive numbers because they're going to have to be the same sign since they multiply to a positive, and they add to a positive, so it would have to be two positives as opposed to two negatives. 3 times 1 multiplied to equal the top, 3, and they add to equal the bottom, 4. And we can use our shortcut since a is equal to 1, since we have a 1 leading our trinomial there. So we can have our parenthesis. The top will still be a plus 3, and the bottom is now going to be a plus 3 and a plus 1. A recap on how we got that on the bottom is we put our variable a here and here in our parentheses with no squared, and then we put our plus 3 here and our plus 1 over here, the number and sign from the sides. So now we say, oh, on the bottom, a plus 3 is multiplying with a plus 1. All of a sudden, we can actually divide the top and this bottom by the a plus 3. So we can simplify that out and say, hey, that's 1. And that's 1. Because we're doing it with the entire top, it's okay. If we were just doing it with part of the top, like maybe just an a, then it wouldn't be okay. But because we're doing it with the whole thing, it ends up being fine. So this actually ends up simplifying to 1 over a plus 1. And that's our answer. So we see this ends up getting quite a lot simpler from where we started with up here to when we go down here. Continuing on to example 5. 5x minus 5 over 9x minus 9. Well, we see the top and the bottom can both be factored with GCFs. The top has a GCF of 5, and it leaves us with x minus 1 inside the parentheses. The bottom is a GCF of 9, and it leaves us also with x minus 1 in the parentheses. So we might notice, hey, x minus 1 and x minus 1. That's something that can be simplified again. So we simplify that and go boom, boom. Since we have multiplication now, 5 is multiplying with x minus 1 and 9 is multiplying with x minus 1. So now we're left with 5 over 9. So we're able to do that when we have multiplication. We're able to divide and simplify, but we weren't able to do it before. And just say, oh, we had an x and we have an x. No, it doesn't work that way. We have to create multiplication first. And then when something's being multiplied, you can take out that whole factor. You can divide out the whole factor. So because x minus 1 was an entire factor and x minus 1 is an entire factor, we're able to divide those. And this 5 over 9 that we're left with is a lot simpler, even just appearance-wise, than the original 5x minus 5 over 9x minus 9 that we started with. Moving on to number 6. The top x plus 3, that can't be factored anymore. We look for a GCF, there is none, and it's two terms, so we look for difference of two squares, but it's not. The bottom, though, is a difference of two squares. So the top will say x plus 3. The bottom ends up becoming the square root of the first x minus square root of the second 3 times square root of the first x plus the square root of the second 3. So x minus 3 and x plus 3. And you can flip those around, it doesn't matter. You can do x plus 3 first. Now, we say, oh, x plus 3 is a factor on the bottom, and we can simplify that out. And I meant to change that to red. And x plus 3 is the top. So it's aka, you could say it's really multiplying with 1 on the top if you wanted. Boom, now we're simplified to 1, and this simplifies to a 1. So we're left with just 1 over x minus 3. Because if we were to even multiply that 1 back in on the bottom, it'd just be the same thing. So once again, we're getting it a lot simpler, and we're simplifying these and making there less clutter when we're done with it. Continuing on, it jumps from 6 to 8. That's a typo I just caught there, so I'll need to go back and fix that. 3m squared minus 48 over 3 times m plus 4. The bottom is actually already factored for us, so someone must have been really nice. And the top, we still need a factor. So we factor out the GCF first, so 3 times the quantity of m squared minus 16 over 3 times m plus 4. Now you might notice right away, hey, there's actually something we can simplify here. So if you notice right away, hey, I can simplify those 3's out, and they both become 1 and 1, you can go ahead and do that. If you don't notice it till later, that's okay too, okay? But I'm going to pretend we notice it right now. Excuse me, I'll pretend we didn't notice it right now. So if we continue on though, m squared minus 16, oh, that can still be factored more. So I can make that a difference of two squares and make it into m minus 4 and m plus 4. And you might be noticing, hey, looky there, we have m plus 4 as a factor on both the top and the bottom. So we can divide those, and we can divide the 3's. Now we're just left with m minus 4 over 1. So just m minus 4. And the only thing that would have changed, guys, is had we divided out these 3's earlier, you just wouldn't have had them here. So that's the only thing that would have changed. Moving on to number 9, 3y squared minus y minus 2, all over 2y squared plus 2y minus 4. We're seeing some couple trinomials here, and we don't get to use the shortcut on either of them. That's okay. Let's start working on the top here. Negative 6 will go on the top because a times c, 3 times negative 2, and negative 1 goes on the bottom. We have a negative and a positive since we're multiplying to a negative. Signs have to be different. And we know the bigger number is going to be negative because they add to a negative. Well, negative 3, positive 2. How it works. So the top can become, and I would recommend writing this off to the side at first. Okay, I'd recommend writing this off to the side at first. That we have, I'll write myself some room here. 3y squared stays the same. The middle changes to minus 3y plus 2y, the sides of our x's. Because if we add those together, again, we get that negative y that we started with in the middle. And that negative 2 stays the same. Now when we go to factor the bottom, I'll change colors so we know the top and the bottom. The bottom actually does have a GCF. So I misspoke earlier when we said we couldn't use a shortcut. Because we actually can. So we factor out a2 there, and we end up with y squared plus y minus 4. Aha, we're in business now. So we make that x And actually, pardon me, guys. I'm going to come back to that in a moment. I'm going to finish factoring out the top first, okay? I'm going to finish factoring out the top first. You can't do these in any order like that of stop midway through, but I think it'll make more sense to us if I stop and to come back to it. So I'm going to group this 4-term polynomial that I created from the first, for the top trinomial, and say, okay, well, what's my GCF of that first parenthesis? 3y squared minus 3y. Well, 3y goes into both. I'm left with y minus 1. My GCF of 2y minus 2, that's a positive 2. I'm left with y minus 1. Same thing, that's Gucci. So we have y minus 1 in the first parenthesis, the common parenthesis there, and then what's left is going to be that 3y plus 2 that's outside both parentheses. Now, I'm going to say, okay, what's on my bottom? So now I'm going to go back and do this, what I was going to do earlier with the denominator of the original problem. And I'm going to factor out that 2 and get y squared plus y minus 2. Now I'm going to make the x. Negative 2 goes on the top, because 1 times negative 2 is negative 2, and 1 goes on the bottom. So I have to have a negative and a positive. Positive's going to have to be bigger this time. Negative 1, positive 2. So those multiplied to negative 2 add up to negative 1. And we can use our shortcut. So we still have that 2 on the outside, but now we have our 2 parentheses. We know y is going to start both, and now we do the number and signs from the sides of the x. So the left part of the x is minus 1, the right part of the x is plus 2, and you can put those in either order. And you might be noticing, hey, we do have a commonality here. We do have something that's shared on the top and the bottom. That y minus 1 can be simplified, because those are both factors. And so we could say 3y plus 2 over 2 times y plus 2. And that would be our answer. Like, Mr. Kossel, all of that, and we still have quite a bit left. Yeah, but if I compare that to my original, I see that's still quite a bit more simplified. Instead of having anything being to the second power, and 3 terms on the top and bottom, I have it now to the first power in both the top and the bottom. And if we wanted to, we really could multiply the bottom back together and still create just 2 terms. And that is all for section 10.1 here with simplifying rational expressions. For the IXL today, this would go along with IXL double G 3, as in Gucci Gang 3, double G there, okay? Have a great day, everybody.